about SSD and flash use in databases. So I'll try to stick to that during the presentation. So the first thing I wanted to say was that when I talk to customers or potential customers, the big thing that I hear is big data is sort of about two things. One is it's about more and more data. It's about all of the data we can collect. It's about sensor data. It's all the different data collection points that exist now on the internet, in telecoms. But it's really also about metadata, which is to say the collections, the social graph, the analysis we do on data. So you can find the data, you can collect it in one place, but that's not really big data. That's just a collection. That's a warehouse. Big data is really about analyzing it using some of the great distributed analytics tools we have today, and that generates a lot of metadata. So the internet is all about cats. We know that. It's not, well, maybe it was about porn at one point, but that's about cats. And so, there's only so many cats in the world, right? The number of cats is not radically growing. It's not on a VC-inspired growth curve. There are only so many cats, right? That's not big data. If you're just dealing with the data that there is today, the amount that you can say about collections of cats, the amount of analysis that you can do about what types they might be, how they're socially connected, that's really what big data is about. It's about the metadata of the internet. It's about finding connections, surfacing connections, sharing those connections company to company. The company across the space there, Gigia, is one of the social networking and analytics companies. They're really creating new metadata about the internet and about the data we have today. The size of this data is much bigger than the individual data about the number of cats or what they do. So I had a discussion with the guys at Twitter a couple months ago, and what they told me the same thing. They said, you know what, the number of tweets, okay, it's going up. The Olympics, it was a good thing because we actually stayed up during the Olympics. But every time a new sales guy comes in, he says, hey, I've got a new opportunity. I've got a new billion-dollar idea of how we can monetize tweets. But I need another index. I need a new way to explore the social graph. I need a new kind of audience calculation about the tweets that we already have. So within Twitter, and I suspect within a lot of the companies that you work at, it's really the indexes that are growing even more than the data itself. And this, I believe, is part of the next generation of big data. Not just about analyzing the data we have. That's great. That's sort of the first wave of big data. The indexes that we can place on it, storing them and making them accessible, is really the second round of big data. Now, what we believe in and what our customers believe in is the real-time aspects of big data. What does this mean? So for us, we deal with a lot of media companies, especially advertising companies. Examples of real-time big data are things like the most recent activities on the internet of a given person. If they've seen a particular ad, you don't want to show that ad again. If they went to a travel site or did a search, you want to retarget advertisements based on that. What we know in advertising is the most recent data is of the highest value. And for that reason, you need to have deferred time match big data, because that creates the models. That becomes, what you do based on the small changes that are moment to moment. But the real-time aspect is also very high value. So the aspect that we see in the marketplace, or the tech stack that we see, is there's these analytics tiers that we have now today, which are things like your Vertica, your Netezza, your Hadoop system, right? Those kind of systems, those are the warehouses where you're going to put all of your data. And those generate, in a batch mode, the different models that you're going to use for predictive analysis. But, and if you're going to generate reports in human time and say, hey, that's a great place to put a new Walmart store or a new wind farm, Well, you know what? You can do all that stuff all in batch time. But if you are dealing with machine-to-machine communication, like advertising is, there's a part of your data that has to be online today and right now. And probably it has to be accessible over APIs. And one of the interesting aspects of API accessible information is that your reputation is on the line. As a company, if you put an API out there and you say, hey, I'm selling access to this API, if you go down for half an hour because of a maintenance window, the guys who bought service and bought access to that API could be very, very upset, and your reputation will suffer. So for people in that kind of space where they have an app server, their app server is going to be interacting with a tier, a database usually of NoSQL type, and please excuse me for putting our logo so large in the center, but the kind of NoSQL clustered high availability stores where you've got a web application tier that's usually running one of these higher scale systems. You can't expose that directly. You wouldn't expose that directly to your analytics tier, right? You're going to expose that to something like a NoSQL tier that can actually absorb the kinds of API traffic that's necessary today. And the same way that an application server uses a NoSQL database, moment by moment, transaction by transaction, that's the access pattern of the data scientist to an analytics system. These are the guys who are poking around, who are finding the patterns, and really doing the day-to-day data. You need to have all four of these components really to participate in the new big data ecosystem. So let's stop for a second. Any questions so far? Any ideas? Great. Yeah.
So when you say real time, how do you define real time? Because a lot of people are trying to define what real time.
So great question. What's real time? I've actually worked in much closer to hard real time spaces, doing things like video ad insertion, where you have to be, exactly when line 23 comes up on your VBI trace to do signal insertion. You've got to be there, otherwise you're toast. So what we're talking about here and where we play is in the sub-millisecond range. So where you're talking about 100, 0.1, 0.2, 0.3 milliseconds. What we find is the level of predictability of this tier is actually very important. If you have some requests that are off taking 200, 300 milliseconds, it creates problems in your architecture. You've got threads that are piling up. You've got API requests that are slow. Having a level of high SLA for your requests that are sub-millisecond is important. So what can you do with this kind of architecture? Well, one of the most interesting, I'll go through a couple of different examples, but fraud detection is a great example for the kind of big data architecture that involves real time and still involves big data on the front side tier. Fraud detection, you can imagine that if you want to try to stop a fraudulent transaction right now in its tracks, as opposed to rolling it back on someone's statement, a week later or a month later, you need to have a set of patterns, and you have to have a set of models. So coming out of your back-end tier, coming out of your Hadoop warehouse, you've got a set of models, but those models are going to involve state transitions within certain behavioral patterns. If I see a particular IP address that is generating a large number of tries for a transaction, because it's searching around and fuzzing an IP address, well, that is likely to be a compromised node, and I want to put it on a blacklist. So that's an example of a pattern that you might find and discover through your warehouse tier. Right? So then over here, you find a pattern, the exact number of tries per second, or the different kind of function that you might use to determine a fraudulent or compromised node. But then, on the front side, you actually have to track, moment by moment, how many tries over how many milliseconds over how many days from a given IP address. So I've gone to a number of different NoSQL conferences, and I always get surprised by daily deals. Because when you talk about that, I think it's small data. I don't know about you guys, but it's like No, really. So you've only got 100 deals active in a given state or zip code or something, and you're having trouble with your databases? And the answer is yes, because the write loads into the system of behavior coming in are still high enough that I hear people talking about, well, we have to have one database instance for writes and another one for our long-term data, et cetera, et cetera, et cetera. So having a front-side tier that is flexible enough to handle high write loads and high read loads ends up being even important for a use case like this. Now, matchmaking, an interesting point about matchmaking is it's not really about dating so much as the biggest case that I hear is gaming. So in online gaming, a lot of monetization is built around making sure that players have a great experience moment to moment. And when they are in a certain pattern in the game, you want to match them with another real-time player, or you want to make a suggestion, or et cetera, et cetera. And how well you do that drives very strongly the monetization of the overall game. So again, you find a pattern with your analytics tier, and then moment by moment, it might take a second to sort through all the different people who you might want to challenge with a game or suggest as a friend or go visit this person's city or something like that. This kind of use case becomes very important for social and social gaming. I've been a little surprised about this case as well, which is imagine that you are doing something like you are a video provider, and you want to be able to make sure that the people who are streaming your video aren't getting a lot of glitches. Well, some of those glitches are caused by a misconfigured PC or a lousy old version of Flash or something like that, right? But some of them are caused by different server errors, different problems on the network, things that someone should go fix. So when someone actually says, hey, I've got glitchy video, or even worse, calls you up for the guys who provide that service, you need to be able to take things like quality records on a moment-by-moment basis and then provide them to the guys providing customer service. And that's actually a moderately large data app, right? If you can take a quality record on a 5-second, 10-second basis, and you have several million different users out there potentially, and then one of them calls in, you want to be able to look at those quality records, very quickly analyze the kind of problem they have, and say, well, you need to update your Flash player, or say, hey, you know what, there's a problem in our infrastructure, and it's our fault, and we're going to go fix it, I'm sorry. Let me change you over to a different code level. Data publishing is another interesting area of real-time data. Imagine the case where, let's say that you own a company that knows a lot about securities, and you can provide analytics on those securities. And that's really your business. You're about rating securities, about figuring out what current risks is, and you need to publish those. You want to publish those to all comers. That's really your business model. Well, again, that's the same model. That's the model where you have a back-end set of analytics, where you're looking at running risk algorithms, pricing options, and then on the front side, you've now got an interface. You're not just publishing in a book, a standard of poor's or a value line book at the library. In the modern world, you've got an API out there, and you're selling that API access for anyone who wants to come in and see what you think the current value of your data is. That's another case of in real time providing analytics and big data access in real time. So one of our biggest customer draws is within advertising. Within advertising, these guys are competing in big data analytics and prediction, because their goal is to always predict click by click what the highest value add to show all of us at any moment is. So they're looking through tons and tons of data in the background. But they have to make decisions millisecond by millisecond about what to fill in every single spot. So this has been Aerospike's largest customer base. We're very happy with those guys, especially because they're very revenue focused. And when I go in there and I tell them, well, I can save you $1 million, you know what, their ears perk up and they're very happy about it. So like dealing with this customer project. So hopefully I've convinced you now that big data isn't just about Hadoop and spinning disk and petabytes. And there's actually a very interesting use case within the terabyte, 10 terabyte use case range. And that's that's really should be considered part of big data. Any thoughts on that? This is where we get to the part about Flash. The point about Flash is, what I hear from a lot of folks is, first of all, Flash is expensive. Hopefully I'll be able to debunk that a bit in the next few minutes. Flash is not safe, as it fails. You get write unavailability, you get burnout, all that stuff is scary. I just want to stick with regular rotational disks. And what I'd like to share with you is the experiences that we've had as a company, and I've had with our customer base, deploying probably in the range, I was trying to calculate it out earlier, maybe across our customer base, 3,000, 4,000, 5,000 SSD devices in production over the last 2.5 to 3 years over a customer base of 30, 40 people, different customers at a very high scale. The message is that 2 years ago, I'm not sure I could have showed you this slide. Flash wasn't really safe. The early implementations were out there. They were a little strange, they were quirky, and there were a lot of failure rates. But we're now into the 3rd generation of Flash. And what has happened over the last 3 to 6 months is really a very large change in both the capabilities and the stability of the different hardware manufacturers, almost across the board. So between the high-end guys like Fusion IO and Violin, sort of the, I would call them mid-tier guys like Samsung and Intel, and then also even in the consumer cases, we have some customers who have chosen to go with sort of large consumer-oriented striping systems. And all of them say that now, with this 3rd generation, Flash is really a great choice for sort of that 1 to 100 terabyte case. So anyone here using SSDs in production today? Yes? Yes? Yeah. So, I mean, this is the fundamental equation that's driving a lot of our customers to Flash. When you're dealing with, say, less than a terabyte, finding a business case where, if a terabyte at $30 a gigabyte, if you can find a $30,000 hardware plus the power to drive it, that's not so bad. It's kind of bad when you're in the garage and you're trying to actually buy some hardware. But once you're a going concern, $30,000 isn't really that bad. Once you get past a terabyte, the equation really changes a lot. The worst part about SSDs is that, RAM is actually the power. So I was attending a conference down in San Diego where there was a lot of discussion about HANA. People talking about HANA for real-time analytics. And it was sort of CEO, CTO level stuff. And the guys were going, well, yeah, I can kind of afford 4 nodes at $50,000 each. That's not so bad. But then the guys came with a power calculation. And they said it was going to be $100,000 per node per year to power the stuff. And that kind of made them, that makes people think twice. A single upfront cost of $200,000, maybe I can swing that, but $400,000 a year starts feeling like for a lot of business cases. What I'll also show is that for a lot of use cases, SSDs will be equally fast. And that's really one of the surprising conclusions. And someone was asking about a white paper that goes over this. I did a post to the High Scalability blog. I don't know if any of you guys are followers. I'm a big fan of Tom and the stuff he does. And the calculation you can do to show that the network interrupts are often the primary bottleneck in these 3rd generation systems. Wouldn't you rather pay $1 as opposed to $30 if your performance is essentially the same, or within 0.1 milliseconds of the same? Most of us. Rotational disk, of course, it's still as much as I'm going to talk about rotational Flash and SSD. Once you're in the rotational use pattern, you're doing petabyte scale, you're doing Hadoop, you're doing table scales. I think rotational will be with us for quite a while, certainly another decade. But we find that really that's where Oracle has already been a strong contender. That's where implementations are already tuned for rotational. So I'm not going to talk about it, but that's not because it's not important. still be out there, especially for these very big warehouse environments. So the equation of cost, so remember 31.1, what does that translate to in terms of performance? Well, memory is, well, it's essentially infinite. An infinite number of operations per second. You're not really doing IOs, right? It's right there, it's on the bus. What that means when we actually try to do database operations in memory is we find, 5 million per server, something like that. Sort of depends on the operation. SSDs are running at about, right now, this third generation, it's about 50,000 per drive. But one of the things that was very interesting in Intel's 12 Gen price line right now is this one particular box they have, which is the R720, I think it's IX or ID or something, extended version. So it's 2U, and it's it's just wide like crazy, and it's just got 2.5-inch chassis all the way across the front. So what you can do with that thing is you can actually put 24 drives in. Let's assume you've got a drive for 2 per system. You can put 20 of these drives in a single chassis for not that much money. I'll show you on the next slide how much money. Well, 50,000 IOPS and 20 of those per drive, that's a lot of IOPS. I mean, that's nearly infinite. If you've got business problems where you need more than 1 million transactions per second per server, that's going to be interesting. At least with a clustered system like ours, you can take more and more servers. You want 20 million? Great, that's 20 servers. Link them all up and go to town. Rotational drives, of course, it's a completely different calculation. This is where Seeks really, that's not their strength. They're good for streaming. So at 20 IOPS versus 50,000, this is really where the entirely new generation has occurred. So let's go through the calculation in greater detail. So today's SSD, again, this is one of these 720 XDs with, let's say, the 200 gig of the newest Intels. These are the 3700s. So the chassis is going to cost you about 8K. And these SSDs, they run about $2 per gig. So a fully packed system with these things will get you about, cost you about total 16K. But you get in one server 4 terabytes. And the raw storage throughput is about 1 million transactions per second. Now, I was down at a company called Gridiron. Our CEO, who's not here today, Bruce, was one of the founders of Gridiron. They were really excited about charging $500,000 for 500,000 transactions per second a year ago. Well, guess what? Single server commodity hardware, you can now exceed that by just paying $16,000 per server. This is the kind of big data and fast data that I think changes the landscape, and that excites us here at Aerospike. So imagine those fraud detection cases where hey, you want to keep a 20K chunk for every IP address on the internet? Great, no problem. You have a packet flow where you're in Verizon's head end, and every single packet, TCP packet that comes by, you want to update that and read and write for fraud detection? Great, you can do it. I mean, this is a level of price performance that's new to me, and in my 29 years of travel. Now let's look at RAM. Now RAM is interesting because, like we said before, it's infinite in IOs, right? Infinite. Infinite's got to be faster, right? Well, part of the problem is that network interfaces have not really caught up. And once you get up to 50,000 transactions per second, you actually start saturating your interrupt bus. And the storage layer starts really fighting with the network layer. Now, you can play some tricks by having your application and your server on the same system to avoid network. You can do batching in some cases, but as database guys, we like to think batching is cheating to some extent. And Russ and I have had a bunch of arguments about that. He did a great post to, by the way, if you want to have any technical questions after I'm done, Russ is a great guy to talk to. He did a great post for high scalability where we did 1 million transactions per second out of DRAM. And a lot of that is about the optimizations of the network. And that's really the bottleneck. The reason we couldn't get 1 to 2 million transactions per second out of DRAM is the network. So in this case, you're still talking about similar kinds of bottlenecks and similar kinds of throughputs. And guess what? 20K. So I actually priced this out on Dell's page. But guess what? Your 20K is now going to buy you only half a terabyte as opposed to 4 terabytes. Yes.
Did you assume what kind of network support? Gigabit or infinity band or high speed? Is that all?
Yeah. So a lot of what we see in the field really is gigabit based, and what we like to recommend is a lot of the gigabit networking that's actually running with the 10 gig chipsets, because they have the best interrupt routing capabilities, multiple queues, and all that kind of stuff. So, I mean, that's really about bandwidth. The real problem in these bottlenecks is actually interrupt, is packets per second. So it's like, when you buy a router, they actually give you a quote for the number of packets per second, as well as the actual throughput. And that really ends up being the bottleneck these days, is interrupts, packets per second, number of essentially disk IOs per second. The actual throughput on the system tends to not be as big a deal. What we end up doing with our customers is we do a simple sizing exercise. So if they are doing, if they want to get up to these speeds, well, in gigabit, they can probably only do 300 byte operations. If they want to do a 1K operation at these speeds, they have to be up at, 4.2, which ends up being 10 gigabits. Does that make sense? You agree? You don't agree?
Yes.
Now, the point about this is storage cost really is a large part of this equation, right? You see, there's sort of the chassis, and then there's the amount of storage at 50-50. With DRAM, it's a little bit higher, but storage really does become a very important part of your overall cost structure in a data center. And most people these days, if you're in the kind of case I'm talking about, if you're doing fraud detection, if you're trying to sell your media data on the internet, you want 2 copies, you want 3 copies. So suddenly it's not only an extra $16,000, it's 16 times 2, 16 times 3 in order to get high availability. So just as an example, what the generational shift is between the second generation and the third generation. A particular customer of ours, one of our longer-term customers, is switching out a bunch of their systems. And they're asking us for recommendations about where to go next. And what they're taking is they're going from 400 gigs of SSD servers up to 4 tera. So they're doing an entire generational leap of a factor of 10 per server. That's where we are today in the generation of flash. Now, all my guys who do silicon actually tell me that this isn't going to hold up. This is probably the biggest change that we're all going to see in flash technology, possibly in our lifetime. This is the big leap forward. Maybe we'll get another factor of 2 in the next year or 2, but their crystal ball says things are going to get more complicated with flash. The problems with MLC and SLC and now eMLC, things are getting a little weirder within flash subsystems. But this is really the big shift. In 1 year, these guys are going from 400 gig systems to 4 tera systems, and doing so, again, at fairly reasonable prices. Fusion.io announced, I think 4 days ago, these particular systems, these actually 2.3 tera cards, they're selling at $4 a gig. So Intel, their enterprise stuff is $2 a gig, their consumer stuff is $1 a gig, and even the high-priced Fusion.io stuff is $4 a gig. So not a lot of spread there between, a year ago, Fusion.io and their high-end SLC stuff was well above $10 to $20 a gig. All that stuff has collapsed down because there are more vendors in the market. The Fusion.io guys know you can go over to Violin, and Violin has a bunch of new products coming out as well at a similar price point. And the same thing with the IBM Texas memory-based stuff, et cetera, et cetera. Everyone's bringing out at this price point, and that's great for all of us. As big data practitioners, the number of choices with flash memory are amazing. This particular customer is out there competing with Google in advertising, right? They're taking the remnant inventory and they are making better optimizations, and they're a platform company. Many different companies come in and plug into their architecture. And one of the benefits that they have is Google's architecture is all RAM-based because it was built 10 years ago when that's all we really had. these guys are essentially getting a generational shift and paying a lot less money for their hardware. I'm sure the guys over at Google, I mean, they're as smart as anyone, so they're probably making this shift as well, but they originally had to go out and buy a lot of RAM and a lot of systems to power that. So, you know, their 40 node clusters are shifting to 4 node clusters, and they're powering, you know, their entire East Coast data layer, which is seeing probably 1 million transactions per second out of that one data center, out of that one cluster, and powering maybe 20% of advertising in the United States on these 4 servers. And that's kind of incredible, right? That's what used to be a data center, what used to be a container, squeezing down into these sizes with the ability to do Flash. You know, and it's not only folks in advertising that have figured out that Flash is critical. If you look at, well, you know, we have one piece of visibility into 2 of the big social companies, Apple and Facebook, because we know from Fusion.io, again, I hate to repeat them, but they do supply both of these guys with a lot of their Flash storage. Enough so that Fusion.io, as a public company, has to disclose how much of their revenue comes from those 2 sources. And guess what? It's 55% of their new updated numbers are 440 million. So we now know at least what Facebook plus Apple is buying in Flash per year in order to keep up with their application demands. So clearly those guys have already figured it out and have already started the shift, or I mean, Facebook's been a big proponent of MySQL with Flash underneath it throughout at least the last 2 years. So, you know, from my view, Flash is now mainstream. Like I was saying about the other one of our main customers is what you can do in terms of competitive company. The fellow I was talking to who is building a new mobile app, and I talked to a guy in Los Altos 6 months ago. He's building a new security layer, and he says, well, with enterprise security, there's more threats you can detect. And a lot of the incumbents, well, you have to go buy a copy of Oracle and spend $2 million on your Oracle installation in order to do threat detection fast enough. And part of his insight, the company he was founding, was to say, hey, you know, if you do this with NoSQL and you do this with SSDs, you can really change the economics for a variety of different applications. You know, and that's, I'd like to say, that's what we're about here in Silicon Valley, right? So let's talk for a second about what you have to do at the software layer, because I know that, you know, a bunch of you guys are people who actually write this kind of software for a living, as we do here at Aerospike. So what did I learn about writing for SSD and SSD optimizations? Well, the first interesting thing about SSDs compared to rotational disks is they are much more amenable to highly parallel architectures. And the reason for that is there's not just one little arm that becomes the bottleneck of the entire device. Instead, what you have internally to the device is a processor or a set of processors and a set of controllers that can all be accessed in parallel. So it sort of depends on the system itself, and part of our benchmarking system, we can determine the best level of parallelism. And some companies are they say, well, we're best for parallel operations. You got to be 64 wide, and then you can really get the throughput. Some guys are out there bragging, you know, well, you only need to go 6 wide or 8 wide to really get our full throughput. You know, but nobody is saying that you just want to go, you know, single step by step. You really have to go parallel with SSD to be able to both read and write at the highest speed. And what you find is that, you know, if you double up on your parallelism, you won't get any latency problems. Latency stays the same, which is kind of great. You know, you just keep getting more and more parallelism, almost for free. What this means in your software is you should be using AIO, and you probably can't get away with thread per single-threaded architectures, simply because the crushing interrupt load into your process is so high that the interrupt subsystem can't run on a core, and your application won't be able to run on a single core either at these levels of speed. The second thing you have to do is you actually have to think about your data access patterns, especially in terms of writes. Now, I'm not talking about getting in bed with an individual SSD's interface, although we're going to see more and more of that. I think the guys at SanDisk are already working on private interface. There's some other options out there. We will see, in my opinion, in the next 5 years, some changes to how storage is accessed. We'll see some new kernel interfaces because guess what? Sectors, well, they're not exactly going away, but this stuff isn't sector-based. So whether it be memory mapped interfaces that are much faster than today's implementations, or we see real kernel calls that are not just give me this sector and read this number of bytes, but possibly key value oriented, which is the underlying metaphor of flash subsystems. You have to do a little bit of thinking about how the flash is accessed in order to get past the bottlenecks of the traditional relational systems. In general, what I find in practice is a system like MySQL will speed up maybe a factor of 2, maybe a factor of 3, if you just take, let's say, last year's MySQL. And so, the MariaDB guys are out there trying to figure out the right optimizations, but they have an existing code base that's not optimized, and they're trying to get their speeds up. That's all well and good. On the other hand, one of the reasons we started with a blank slate here at Aerospike was we said, you know what, Flash is just going to be different, and the way you index it is going to be different, the way you write to it is going to be different. So think about SSD layouts, think about how chips work, think about how controllers work, because it's not just a single arm, and you'll find that you can write software that is an order of magnitude faster than using a rotational style model. And that's part of what a lot of structured subsystems like as well, because the way Flash works is that writes happen in very large blocks. And that's the underlying reality of how the chips work. I like to think of it like one of those pin boards, where you can sort of put your face in it and it sort of shows your face. You've got to, or an Etch-a-Sketch. You can erase it, but it takes a while. You got to shake it, and then sort of it all goes back to 0. Whereas you can change individual bits very, very quickly. That's how Flash works. So writing happens on sort of a large basis, which is very good for a log structured implementation, where you can read individual pieces very quickly. So it's asymmetric. Making that, having that insight in your code allows you to go a lot faster. What I'd also like to suggest is, there's a lot of theory out there, and there's a lot of people talking about going fast. But what we should all be doing as a database community and practitioners of big data is a lot more measurement than we do today, right? So people say, X is fast or Y is fast, or we're the fastest database. But we all have a good tool out there, which is the YCSB, the Yahoo Cloud Serving Benchmarks. And all benchmarks are flawed. That's sort of a reality of the universe, right? But at least we're now in an open source world where you can just go to the GitHub repository, download the plugins, create your own plugin for your own system, and try a variety of these NoSQL systems, or even SQL systems, right? There's a plugin for MySQL for YCSB as well. So you can, if those guys come out with a new optimized storage layer, you can actually see what it's doing, or an in-memory style solution. Now, this is the part where I'm going to say at least some nice things about our company. What we do is, what we found is that with Flash, we were able to strongly outperform some of the other NoSQL companies when talking about Flash. So this report is available on Thumbtack's website. So there's a company, a real nice bunch of guys out of New York called Thumbtack, and they did all this work themselves. They're partners with Cassandra, they're partners with, they talk to DataStax, and they're partners with Couchbase and Mongo, recommend them for some situations. Because it's really fast to develop those Mongo applications with JSON interfaces. I love it. I use them for some applications. But when you're dealing with SSDs, what we found was really a dramatic difference in throughput. And also, the limitations of Cassandra and Mongo around single core access, as well as the inefficiencies of Java, kind of hold it back. So let's go out there and measure our solutions. And yes.
So there was a study done by a company called Taurus, is it?
Yes.
So have you part of that study?
No, that was done, I think, a little over a year ago. So it's one of the older ones. And we did not yet have a Yahoo plugin at that point. They didn't contact us. So.
Do you know how big the database in this benchmark?
Yes. So, I mean, one of the problems with these higher throughput tests is that your question was, how do you avoid bottlenecking on the network? So they didn't want to put in all 10 gig amongst their servers. So they did the whole test on, I think, bonded 2 gig. So that made, in order to create a throughput test, they had to use smaller objects. So the database itself, I think, is maybe 30 million objects, which is to say small, big enough to not fit in memory for their test case. And the objects were fairly small. But, I mean, that's why it's a benchmark. It's focusing on that particular use case. This case is also built not on a uniform distribution, but on the Zipfian distribution. So it generates hotkeys as well, which is an interesting challenge. But you can go read it yourself. And what's also great about YCSB is, if you don't like the way this benchmark was run, the ability to run it yourself is so easy. It's all Java-based. You download the packages, run it yourself. So that's the end of what I have to say. One thing we're about is doing things that haven't been done before. When we try to replace existing incumbent databases, it never works. Because if you want to get a factor of 2 out of your database, go buy some more hardware, go enjoy Moore's Law. If the problem is really, I want to attack a new business, I want to do a kind of security algorithm that's never been done, or a advertising optimization, that's when you have to start reaching for some more aggressive technology. So we have some T-shirts over by the door with this image on it. It's safely in the public domain, so you recognize it from what was the movie that had this in it?
Hugo.
Hugo, thank you. But the Jules Verne, so that's they're shooting the movie. So. Any other questions?
So, two-part question. For a new customer to adopt Aerospike, there's a learning curve. How disruptive is the process of adopting the technology to the existing RDBMS they're probably running?
That gets exactly to what I was just saying a moment ago, which is it's not about replacing the existing database. It's really about I have an adjunct, I have a new workload, I have a new business case. I'm starting from scratch. I have to learn something anyway.
However, and I remember that point. However, my point, the question I'm asking is somewhat different. In order to adapt this technology, you're probably going to have probably some legacy development guys who are familiar with RDBMS but are not familiar with Aerospike. And they're going to have to adapt to it, and they're going to have to pull data from their existing legacy technology to populate Aerospike. So how disruptive is that process? What do they have to go through in order to make that transition?
It's really not that bad. So we have a row-based system. We have tables. We have columns. The columns have values. So our path to SQL is fairly straightforward. I've been saying NoSQL a bunch here, but I actually don't believe in NoSQL at all. Although I won't tell you that line about it being not only SQL. That's forget that. But you still got to have typed data, and it still makes sense to address collections of data via column names, and even to go beyond it into the document structure. So a lot of the concepts, at least from a data layout format, end up being the same. You can still have a CSV loader. You can still be able to do sort of ETL transforms in a fairly straightforward fashion. The biggest difference and the biggest disruption that does happen is you do have to think differently about joins in a clustered environment. And that's really not so much about relational, and it really is about a distributed system. And one of the reasons why, Oracle RAC, nobody really implements it past 4 to 5 nodes because joins become problematic in distributed systems. So I would say, that's even deeper than what you're talking about do they know about these kind of tooling.
But wouldn't you just augment the relational database rather than trying to replace it? Meaning that you would look at unstructured data rather than really trying to replace relational databases.
Yeah, exactly. We're not about replacing relational databases. We're about you've got a different problem, and there's programmers coming up who are more comfortable writing a small indexed MapReduce job than they are trying to figure out. I've seen people. I've gone into a customer meeting. I think it was in Jersey City. The guy showed me some of the SQL statements, and I mean, it's the whole screen, right? It's this hairy, crazy difference between a SQL system, and for those guys, it's disruptive to bring in a NoSQL solution. But if you've gotten in bed that deep with your existing database vendor, first of all, you can't even switch to a SQL system. So really, we try to say, look, if that's your problem, stick with your current system. And we're actually finding that that kind of conversion isn't the biggest problem.
You would just augment the existing relational database.
Yeah, exactly. And also, it's working within a new framework of applications and application writers. What I've been impressed with these days is, there's a lot been written and blogged about the changes in the enterprise and enterprise software. We're still a software company. We have direct sales, and we go into companies where we're dealing with a small group of 5 or 6 people who have been tasked to build a new data layer and build a new application. You know what? They don't really look as different in Time Warner Center than they do in South of Market. It's still 6 or 7 guys trying to use Scrum and put together some cool piece of technology.
How does aerospace differ than other competitors in the industry in terms of architecture?
In terms of architecture, one difference is how we treat transactions. So within the new distributed database world, I would say there's one part of the world where it's all about delayed consistency and things like Dynamo style transactions according to the Dynamo paper. That's what Cassandra uses. That's what React uses. And they'll never get to immediate consistency. And that's sort of one part of it. The benefits of that are you can build larger clusters because you're never ever going, you don't have the problems of trying to coordinate a large cluster. And then there's another part of the world in which I would say is closer to MongoDB as well as us, where it really is about having a master, in our case on a row-by-row basis. They have it partition by partition. And being able to take that transaction and effectively commit it within a set of systems. So first of all, we're on that side of the fence. We're on the side of the fence where we support ACID on a row-by-row basis. We'll get to multi-row transactions eventually. We believe in the database fundamentals. My co-founder is IBM Almaden, University of Wisconsin, shared nothing guy, and he wouldn't be at a company where we didn't take transactions seriously.
Does Aerospike support both row-wise and as well as column-based tables?
Not yet. So we've really focused originally on row-based because column has been primarily the world of analytics systems and things like Vertica famously, but also Cassandra. Right? Cassandra is very good at column operations. People who end up using it for row-based optimization systems end up being a little dissatisfied. Another thing is we've built our system from the ground up, and that shows in terms of performance graphs. So being able to having a graph with competitors that is showing that kind of aggressive performance differences.
Is it open source system or?
No. So we open source our clients. And that's because, just myself as a developer, if I have to bring a bunch of code into, my application, I want to see it. But we keep this server as closed source currently. Would we ever open source it? Maybe. Part of what it is it's partially about price. So there's some people who want to read the code because they want to see the code. I'm all for that. On the other hand, if what you want to do is you want to say, well, Russ doesn't deserve to get any money. Well, I've got a problem with that because Russ is a great guy and he deserves what we all deserve in terms of a nice paycheck.
Do you have any performance benchmark with your competitor databases?
That was right back here.
Mentioned about large block writes. Can you comment? I believe Cassandra and Mongo also do large block writes. My perception is that that's not necessarily the best way on an SSD based platform. Can you comment on how are they different from the other?
So Cassandra uses the file system. So you don't really know what Cassandra doesn't really know what the underlying file system is doing in terms of locking. A lot of people who run Cassandra run it on Strike RAID. Again, so you don't necessarily know what the RAID card's doing underneath. So I don't want to comment on that because it's actually kind of complicated. I haven't looked internally at what Mongo is doing in their 2.2 release. They supposedly have some optimizations now in that. What they've done previously is they've done memory mapped I/O. So they end up doing a lot of small writes sort of all over memory and attempts to let the operating system try to do the aggregation. And that ends up being a pretty poor optimization for SSDs. If you want to know, I can probably talk to you later about why large block writes end up being better. But let me just say one thing. Over time, that optimization will fade away. My experience building video servers in the mid-90s was there was a lot of optimizations based on seek patterns within different rotational drives and thermal recalibration cycles and stuff like that. And companies saying, hey, we're better because we understand disk drives. And guess what? 2 years later, they had no competitive advantage. That's what's going to happen in SSDs. Eventually, the SSD makers, the third generation we have today, when you get up to the fifth generation, small block writes are going to be the right optimization. That is eventually the right answer. Today, we're bottlenecked, and the reason we have to do large block is primarily due to implementation failures in drive firmware. Right there.
How does Aerospike compare to Redis?
With Redis?
Yeah.
So first of all, I love Redis. And Russ loves Redis. He built an entire SQL query engine called AlchemyDB on top of Redis. The problem with Redis, there's sort of two problems with Redis. One is philosophically they're really against SSDs, right? The guy who runs Redis to a great extent has said, we're never going to do SSDs. SSDs are just not the right way, and we don't believe that. Interestingly, when I was in China, there's a huge Redis community over there at the social networking sites. They've actually got private forks of Redis that are running on top of SSDs. And of course, they're not sharing that back with the community because why should they? That's one big difference with Redis. One benefit of Redis, of course, is the rich operations that you can do in Redis. Things like lpush, lpop, stuff like that. We have ways, and we have plans over the next quarter or so to get a lot of those operations because they're really, really useful. The other issue with Redis is building large-scale Redis systems. You have to build out a sharding layer. And that doesn't mean you can't do it, but part of what we're proposing is, and the entire distributed database community is, writing sharding yourself. Do you really want to spend that year writing a sharding layer and going through all those bugs? Because every one that you do from scratch, even if you take someone else's, you end up with a whole bunch of pain. The distributed database community here is to help you not have to build your own shard layer. And there are some shard layers for those. I would say that's the difference.
Similar question actually. There's a open source database called FlexDB or RethinkDB, I don't remember, but they claim it's also optimized on an SSD. Can you comment on how you looked at that or not?
Yeah, Rethink. You're thinking about Rethink. I wouldn't exactly call them open source. They're venture backed, just like 10gen, and just like us. They were originally over on Dana Street, I think, and their big claim to fame was that they were going to do SQL on top of SSDs. They went through their first round of funding and they pared back to being a key value store. Everything that I've heard about them is they don't have the kind of customer traction we do, and so you can't, just in terms of downloading it and running it, we don't really see them out there in the marketplace. So a lot of claims, and I haven't seen the proof yet myself. If there's someone here from Rethink, it could be, stand up and tell us. Yes?
So can you comment on the scalability, for example, like you showed about 4 terabyte node today, right? So how, especially given that now you're kind of consistency, like ASP semantics. Can you kind of talk both on the number of nodes per cluster and also the amount of storage per node?
So immediate consistency systems are still going to focus on smaller clusters. There are ways to get beyond that, and so we've got our own particular technical ideas. But frankly, when you can do 1 million transactions, 500,000 transactions per second per server, you can get away with sticking in the 10, 20, 50, 100 server range per cluster. That's still a very challenging, interesting problem to handle. A trillion objects at 10 to 50 million transactions a second. So that's sort of the sweet spot there. Whereas the fully delayed consistency model systems, like say your Cassandra, your Riyadh, that really they focus on delayed copies and async replication. Those systems can go up to 1,000 nodes much more easily. On the other hand, I think that a fast immediate consistency system will beat them still in terms of transactions per cluster. So you really don't care about the number of nodes, you really care about the number of transactions.
I think I'm thinking more like if you in your kind of indexing is memory, if you kind of like using that kind of a cluster, very naturally to argument or something else.
I'm philosophically a TCP guy, and I think there's some interesting some interesting technical things to say right now about the state of networking. I look forward to having another meetup about that. But I'll leave you with one tidbit, which is that we recently did a trial, because measure your results, of TCP-based versus UDP-based. And we found TCP was outperforming UDP by at least 40%. At least 40%. And we attribute that to basically more optimizations within the Linux kernel and better support by Intel in their chipsets, not only for TOE, but actually for interrupt handling. So there's another problem within the Linux kernel that the Facebook guys have been talking about with basically statistics logs and statistics counters. There's some people who have been doing private builds in the kernel to get around some of that stuff. So all that being considered, RDMA is going to be interesting. But my experience in networking has been, I really don't like going private, and something that RDMA is still it's a hard sell in a lot of environments. If I walk in and I say, look, TCP, it's fine for now, that goes a long way. Where we're going to be in 5 years, though, I don't know. Maybe we'll have a lot more RDMA. Maybe the optimization of transactional memory. I mean, that recently got committed in the kernel. Those are some very interesting areas to database practitioners.
So how many nodes in your customer, the maximum node that you supported now?
So we focus on, we have some customers, some of our smaller customers, in the sort of 3 to 4 node cases. We have customers up in the 40 to 50 node per cluster range as well.
So if you look at the 3 or 4 nodes, maybe the pricing is a key issue. You compete with Oracle, is that true? Or?
Pricing, although Gino's here, if you really want to talk about pricing, advice on Aerospike, he's your guy. When I founded the company, I thought really hard about pricing. And what I found, especially talking to my co-founder Srini and one of our advisors, a guy named John Paulo, who was at Salesforce during their original scale-out before they went public, and also he built the AOL streaming system. One of the keys to reliability is having enough hardware. It's kind of a basic truth. If you don't have enough hardware, I'm just a software guy. There's only so much I can do. So I want my customers to buy the right amount of hardware. And I don't want to stand in their way. And if I do a per node license and I say you can only have 10 nodes, guess what? They're only going to have 10 nodes. Even when their ops guy says, well, we really need to make it a little bigger because these are the failure rates we've been finding. So we don't sell per node. We don't sell per core. We sell per data size, which is the same model that Vertica uses. I asked all my friends who buy databases, what's your favorite price? I know you don't like to pay for databases, so the first answer is free. But if you have to pay for a database, what model do you like the most? And everyone hates per node because, yeah, it scales with the size of your system, but you end up buying too little hardware and building a fragile system. So by charging per data and saying, hey, look, your ops guys, as many nodes as they want to have, as many copies of the data as you want to have, that's your problem. You go write a check to Dell. I mean, that's between you and Dell. Or HP or whoever your hardware provider is, or Rackspace if you're doing managed hosting. That's not our problem. Our problem is we're solving a business problem for your data. So we price by data.
Because in your presentation, you emphasize a lot SSD, right? And the Fusion I/O also support Oracle, right? And something.
Yeah.
So how you guys compete?
Well, our relationship with Fusion IO is a little interesting, and all the Flash players are trying not to be commodity guys, right? So if you look at Fusion IO's 10Q, they're all about building higher level abstractions. They bought Turbo Cache, right? So sometimes you have what's the word, frenemy. So the Flash providers are trying to come up stack and not be a commodity, and we're trying to work with all the different providers. And I go talk to Fusion IO, and the next day I go talk to Violin, and I try to play them against each other. So that's the game, right?
So did you change your code to optimize the spatial capability or no? I mean,
we did one proof of concept with them. So we were this last summer at the demo conference in San Jose. So you can find that on the internet, the demo that we did with Fusion IO with their native key value interface. But they've never productized that interface. So we have the code ready to go, and they never productized it. So we have never taken it to GA quality. And